All right, this video is going to cover notes 8.3. This will be going over day 2 of our special right triangles. So in day 1 of our special right triangles notes, we looked at the 45, 45, 90 special right triangle. Today, what we're going to be looking at is the second special type of right triangle, which is known as the 30, 60, 90 special right triangle. So this one is a little bit harder to work with. So we're just going to start off by understanding the relationship between each of the side lengths in a 30, 60, 90 special right triangle. Okay, so what you'll notice here is, just as a review, remember that when we're looking at a right triangle, what we refer to as the hypotenuse is the side across the 90 degrees. So this is our hypotenuse. And the other sides are called legs. So this is a leg and this is a leg. So in a 30, 60, 90 special right triangle, it's noted that across the 30 degrees, let me actually do this in a kind of thinner color here, but across the 30 degrees, we have our side length represented by A. Across the 60 degrees, this will be whatever that side length is, A, multiplied by the square root of 3. And then your hypotenuse, which is across the 90, is going to be your side represented by 2A. Okay. So I'm just putting the little dotted lines there to get you to realize that, hey, whenever I'm looking at the side length across the 30 degrees here in blue, it's going to be labeled as A. Across the 60 degrees is A square root of 3. And across the 90 degrees, the hypotenuse is 2A. So filling that out here, what you'll see here is that the shorter leg here would be A. The longer leg here would be that amount, A, multiplied by the square root of 3. And the hypotenuse would be 2A. So the relationship between the side lengths are as follows. This side across the 30 labeled as A, the hypotenuse is going to be 2 times that amount. So it'll be double that amount. The longer leg, which is across the 60 degrees, will be the length of the shorter leg just multiplied by the square root of 3. Okay. So what I'm going to do here is I'm just going to erase the little dotted line so that this is a little cleaner to look at. And similar to what we did yesterday, we're going to go ahead and label all of our sides the following way with the letters A square root of 3, and 2A with the examples that we do in the notes today. Okay. One important thing to note here is that your shorter leg is always going to be opposite the 30-degree angle. And the longer leg is always going to be opposite of the 60-degree angle. So let's just jump into some examples so that we can see how this is going to work. So as we look at the examples down below, what you'll notice here is that in these examples, there are no directions, but it's assumed that they want you to find the missing variables. So we want to find X and Y in number 1. Well, the very first thing that I recommend that you start with is definitely start with the angle measures, right? If I'm looking at all 3 angles in the triangle, I know that all 3 angles add up to 180, right? So right now, if I'm looking at all 3 angles adding up to 180, I know one of them is 90. So if I take away 90 and I take away the other angle of 60, 180 minus 90 is 90. Minus 60 leaves us with 30 degrees. That tells us that this missing angle here would have to be 30. I'll write that a little nicer here. So always start by filling in any missing angles if you have any in your right triangles. Now that we know that we're looking at a 30, 60, 90 special right triangle, we can go ahead and start labeling our side lengths. Remember that we said earlier across the 30 degrees is labeled as A. So across the 30, we're going to label this as A. Across the 60 degrees is A square root of 3. So across the 60 is this side length Y. So this is our A square root of 3 side. And the hypotenuse is across the 90, which is our 2A side. So similar to what we did yesterday, what we're going to look at here is, what is the side length that was provided? They told us that this side is 17, and that happens to represent the side that we labeled as A. So we can write an equation that says this. In this case, A has to equal 17. Well, if A equals 17, we now have enough information to find out the values of X and Y. Let's start with X here. X is represented by 2A. So if X is equal to 2 times A, we just found out that A is 17. So we're going to take this amount and plug it in. X would be equal to, here in this case, 2 times A, which we found A to be 17. So this becomes 2 times 17, and we see here that X is equal to 2 times 17 gives us 34. So X is equal to 34. Next, we're going to find Y. If we look at the value for Y, I'm going to do this off to the left here. Y is represented by this side length right here, which is our A square root of 3 side. So if Y is equal to A square root of 3, then what we're going to do is we're going to take our value for A, which we got, which was 17, and plug it in for A. Doing so, what we're going to get is y is equal to, well, a is 17, and that's going to be multiplied by the square root of 3. I guess let me do this in black so we can actually see that 17 being plugged in here. So we get 17, and then that a value of 17 is being multiplied by square root of 3. So it becomes 17 square root of 3. So our y value is 17 square root of 3. And so that's the relationship of the side lengths. More or less, we're doing the same thing that we did yesterday, except now we have a total of 3 different ways that we label the sides here. Okay. One thing I do want to point out here is that pretty much anytime you do these special right triangle problems, your objective is going to be to find the value of a. This one made it real easy for us because they told us the side represented as a. Okay. But that's not always going to be the case in the problems that we look at. So for example, let's look at the next one. Let's look at number 2. Okay. If we look at number 2, again, we're going to start with our angles here. If I'm starting with the angles here, then we see here that I have a 90, we have a 60. That means that this third angle is going to have to be 30. So if that angle is 30, remember that we're going to start by labeling our sides. Across the 30 is A. So across the 30 here, this is A. Across the 60 in our triangle is going to be the a square root of 3 side. So this is a square root of 3. And then across the 90, our hypotenuse is 2a, right? So pretty much we're labeling every single 30, 60, 90 triangle the following way. And we're going to focus our attention on the side they gave us. The side they gave us here is this one right here, 5 square root of 3. That 5 square root of 3 is my a square root of 3 side. So we're going to write an equation that says that. What we see here is that our a square root of 3 side is going to be equal to, well, they told us it's 5 square root of 3. And again, like I just mentioned a little while ago, the objective here is that you want to find the value of a. So if I have a times the square root of 3, if I want to solve for a, I need to cancel the times square root of 3. The opposite of multiplying square root of 3 would be to divide by square root of 3. So we're going to divide both sides by the square root of 3. Doing so cancels out the square roots of 3 here, leaving you with a is equal to, well, 5 square root of 3 over square root of 3. The square root of 3's here also cancel, leaving you with a is equal to 5. So if a is equal to 5, now we pretty much are set up to find the other missing side lengths. We can start off by finding the value of x. X is represented as 2a. So if x is my side length of 2 times a, then x is simply 2 multiplied by the value of a, which a is 5. So this is really just 2 times 5, which gives us 10. So x is equal to 10. We can use that same logic here to find the value of y. Well, y is simply equal to a. Well, y is equal to a. We found out that a is 5. So y is just 5. And there's our answers. Okay. And we should hopefully see this pattern here. What I'm going to do here is I'm going to kind of erase the labeling that we have here so that you can see the patterns that we have in the picture labeled below present in number 2. So if we were to just kind of just erase all this and just put down the numbers that we got for our answers, what you would see here is that y, we got a length of 5. And the 90, across the 90, the hypotenuse, we got a length of x, which is 10. So what you should be noticing here is pretty much the same pattern that we have going on up here. Across the 30 is a. Here's across the 30, our a is 5. So the hypotenuse is going to be double that amount, 2 times that amount, which is 10. And we see that here. And the side that is across the 60 degrees, our a square root of 3 side, is going to be just however long this shorter leg is multiplied by the square root of 3. So this side here is our side across the 60. It's going to be that shorter leg amount 5 just multiplied by the square root of 3. So that pattern is present here. Okay, let's look at the next one. Okay, there's a lot of examples in the notes that we're looking at for today because we have just very unique scenarios for all the problems that we look at. And we want to make sure that we cover all those possible scenarios you're going to run into. So we'll continue on with the next one. Number 3. Number 3, they're asking us for finding the values of x and y. So here I see a 90, that's a 30. That means that this third missing angle would have to be 60. And if I label my triangle, you just want to make sure you're labeling it according to this picture. Across the 30 is a. So across the 30 would be here, this is a. Across the 60 is a square root of 3. Across the 60, this is a square root of 3. And across the 90, our hypotenuse is 2a. So across the 90, the hypotenuse here is 2a. And what you'll notice in this case, they gave us the side length of 32, which represents your 2a. So let's build an equation that says that. In this case, this would mean that 2a has to equal 32. Understanding that, we now have an equation that allows us to solve for a. If I want to solve for a, I need to cancel the 2 out. How am I going to cancel the 2 out? By dividing by 2. If we divide both sides by 2, we're left with a is equal to 32 divided by 2, which gives us 16. Well, if a equals 16, well, now I can find the values of x and y. Let's start with x because that one should be the one that's the most straightforward. X is simply just equal to a. So if x is equal to a, we found out that a is 16, so that tells us x is just equal to 16. So x is equal to 16. Y, on the other hand, y is represented by our a square root of 3 side. So y is equal to a times the square root of 3. Well, we found out what a was. How much was a? A was 16. So we're going to take that 16 and plug it in for a here. So this becomes 16, and now we're going to multiply that by the square root of 3. So y is going to become 16 square root of 3. And there's our answer for number 3. Okay, so pretty much the common theme here is this. If you want to break this down into steps, step 1 is going to be to label your missing angles. Step 2 is to label your sides as a square root of 3, and 2a. Step number 3 is build an equation with your given side length and solve for a. Okay, in every single problem, you want to find the value of a. Okay, let's practice with a few more here on the next slide. If I look at the next slide, these are going to slowly start to kind of scale up in difficulty. So if we look at these problems in the level 2 section, let's go ahead and go through this a little bit faster, at least the setup. If we're looking at our angles, we start by labeling our angles. If that's 90, that's 30. This must be 60 degrees. And if I'm labeling it, okay, remember that the way that we labeled it was the following. Should have this here for reference so that we're not flipping back and forth here in the notes. If this is 30 degrees, across the 30 is a. If this is 60 degrees, across the 60 is your a square root of 3 side. And the hypotenuse was 2a. Okay, so that's how we labeled our 30, 60, 90. So let's label it in this following picture. Across the 30, this would be a. Across the 60, it's a square root of 3. And across the 90, the hypotenuse is 2a. Focusing our attention here on the side that was provided, they gave us this side of 12. That side of 12 represents your a square root of 3 side. So if I'm going to build an equation with that given side length, then we can say here that a square root of 3 has to equal 12. And again, remember that the objective here is you want to solve for the value of a. So if I want to solve for the value of a here, we have a multiplied by the square root of 3. How do I cancel multiplying a square root of 3? By doing the opposite. So we're going to divide by square root of 3 on both sides. Doing so will cancel this out, leaving us with a is equal to 12 divided by the square root of 3. The only problem with this is that we cannot have a square root in the denominator, so I cannot have a square root in the bottom of a fraction. To fix this, we rationalize the denominator by multiplying the top and bottom by that square root found in the denominator, which in this case is square root of 3. So to fix this, we're going to multiply the top and the bottom by the square root of 3. So doing so, multiplying straight across the top, 12 times the square root of 3 is, well, 12 square root of 3. On the bottom, square root of 3 times the square root of 3, you can multiply square roots with other square roots. You work with the numbers underneath. 3 times 3 gives us 9. So square root of 3 times square root of 3 gives us the square root of 9. If I keep going here, we know that what the square root of 9 is. On the bottom, the square root of 9 is just going to be 3. And on the top, we have 12 times the square root of 3. So you might be thinking that maybe I can cancel these 3's out, but I can't, right? This 3 is under a square root. This 3 on the bottom is not. So those two cannot interact with one another when we're dividing. So what we can do, though, is we can work with just the numbers that we have here highlighted in green. 12, I can't divide that by 3. If I divide 12 by 3, we'll find out that our a value here is going to be 12 divided by 3 is 4, and then we still have that square root of 3 there. So for this particular problem, a is equal to 4 square root of 3. Now that we know what a is, I can focus our attention on finding the value of x. The value of x is given by 2 times a. Well, we already know that a value, so I'm going to plug it in. We're going to take this a value here, and we're going to plug it in for a right here. So this would be x is equal to 2 multiplied by a, which a here we just said is 4 square root of 3. Now, when you multiply this, in this situation, you're just going to be working with the numbers in front. Just multiply the 2 times the 4. We multiply those two together, we get 8 square root of 3. So the value of x is 8 square root of 3. If I want to find the value of y, well, y is simply just our side length of a. So if y is just our side length of a, we already know what a is. It's 4 root 3. So y is equal to 4 square root of 3. And there's our answer. Okay, let's hit another one here, and then we'll look at Kind of some slightly more challenging questions. So number 5 says find the values of x and y. Again, we're looking at filling in our missing angles. So let's just call this 30. And what we're going to do now is we're going to label our triangle. Okay. Across the 30 is A. So across the 30 here, this is A. Across the 60, A squared of 3. Across the 60, this is A squared of 3. And across the 90, that's your hypotenuse, which is 2A. So this is 2A. So we're working with a given side length that was provided to us. The given side length here is 8 square root of 5. That represents our side of 2A. So we're going to write an equation that says that. So if I write an equation that says that, then we can say the following, that 2A has to equal 8 times the square root of 5. Well, if that's the case, then we need to solve for A. How do I solve for A here? I need to cancel out the times 2, so divide by 2. That cancels out, leaving you with A is equal to, well, you just divide the numbers right here. 8 divided by 2 gives you 4. So we're left with 4 square root of 5. The value for A is 4 square root of 5. And we need to find the value of x and y here. Okay, so I'm just going to start with x since I'm going in order here. X is equal to A multiplied by the square root of 3. Well, we already know what A is. A is 4 square root of 5. So we're going to take that and plug it in here to the equation that we just wrote. So what this is going to give us is x is equal to, well, A, which is 4 square root of 5. And then we're going to take that amount and multiply it by the square root of 3. So we're going to write now times square root of 3. If we're going to multiply this out, the way you're going to multiply this is, well, square roots can operate with other square roots when it comes to multiplication. So we're going to just multiply the numbers underneath. The 4 stays the same on the outside, but now we're working with underneath the square root. 5 times 3 gives us 15. So our value for x is 4 times the square root of 15. What you might want to consider checking is the square root of 15 a nice number? I'm telling you right now that it's not. And we actually would then, first instinct would be to simplify. But if I try to simplify here, I break it down into 3 times 5. There are no pairs of the same numbers. So this is already in simplest form. So x is equal to 4 square root of 15. And then we need to find y. Y is our side labeled as A. So if y is equal to A, we already know what A is. A is 4 square root of 5. That just means y is equal to 4 square root of 5. So our answer here is 4 square root of 5 for y. Okay. So again, same theme here. Step 1, label your missing angles. Step 2, label your sides as A squared of 3, 2A. Set up an equation and solve for A. After that, everything starts to come together. So let's look at the next section of our notes here. The next section of our notes kind of has some helpful reminders. So just in this section of the notes, we just want to recall that whenever we're looking at perimeter, perimeter is found by adding up all of the sides. So perimeter, we find it by adding up all the sides of a shape. Now, the other thing we want to just kind of review and recall here is that an equilateral triangle, what does it mean for a triangle to be equilateral? That means that all sides are congruent. So what that would mean in this case is that, hey, all these sides would be congruent. We should also make note of here is that if a triangle is equilateral, that means that all angles are congruent. And if all angles are congruent inside this triangle, then that would mean that all 3 angles have to add up to 180, but they also have to all be congruent to one another, right? So what this would basically tell us here is that each angle measure is going to be 60 degrees. Okay, this is super, super important because we do run into special word problems that deal with this. Okay, if you have an equilateral triangle, things to remember here is that all sides are congruent and each angle measure is 60 degrees. Okay, so we're going to kind of use that to help us with number 6. Okay, number 6 deals with an equilateral triangle has a perimeter of 24 centimeters. Find the length of the altitude. So if we're looking here, okay, kind of just leave that equilateral triangle right here. This equilateral triangle is what we're looking at. So I'm going to draw a picture of it. Equilateral triangle means that all of the sides are congruent. Not only that, but they also tell you that we have a perimeter of 24. Perimeter, remember, we said is found by adding up all the sides. So if I'm working backwards here, if I want to find the length of each side has to be congruent. We have a total of 3 sides. So if we just do 24 divided by 3, that will tell us that we get 8. This means that every single side in this equilateral triangle has to be 8. Okay? Because if I were to add all these up, 8 plus 8 plus 8 is where that perimeter of 24 comes from. Now, the question here is asking, find the length of the altitude. Okay. So if I were to look at finding the length of this altitude, here's our altitude in black. They want us to find the length of that, which I'm going to call that x. Okay. One special important thing that you need to realize here is the part that we have starred here. Okay. The part that we have starred here says that when you drop an altitude in an isosceles or an equilateral triangle, it bisects the base and the vertex angle. So remember that this altitude is going to serve as a bisector. This altitude is going to basically cut anything in its path in half. Okay. And one thing that we didn't label here was about the angles of an equilateral triangle. Earlier, we said that an equilateral triangle has each angle measuring 60 degrees. So that would mean that, hey, this is 60, this is 60, and this top angle right here is also 60. But what we're saying here is happening, and I'm going to zoom in here so we can look at this picture a little clearer. What we're saying here is happening is that this altitude is basically cutting this angle in half. So if I were to cut that angle of 60 in half, what we'd basically be working with here is 30 degrees and 30 degrees. Write that a little thinner here. So that would mean that this is 30 and this is 30, right? And that's coming from us taking 60 and cutting it in half, dividing by 2. Okay. So right now we're working with kind of a complicated looking picture, but what I would like to bring your attention to is to what I'm highlighting here in yellow. What I'm highlighting here in yellow essentially is what we looked at throughout the notes. What we basically just created for this problem is a 30, 60, 90 special right triangle. Okay. The other thing we want to make note of here is this. Okay. We understand that the altitude is going to cut that angle in half, but what I said earlier is that when you drop an altitude in an isosceles or an equilateral triangle, it does bisect the base as well. So it bisects the base and the vertex angle. The vertex angle here is 60. That already got bisected to give you 30 and 30. But this also means that our base, the base length of 8, is also being bisected. So that means that this would be 4 and 4. Okay. Remember, just easiest way to remember here is that if it's an equilateral triangle or an isosceles triangle, the altitude is going to bisect everything in its path. So it bisected this angle of 60 and it's bisecting this bottom side of 8. Okay. So what we're going to work with here is this yellow highlighted triangle. I'm just going to pull it out of the picture that we have here. And we see here that this is 60. This top angle here is 30. And I'm going to label our sides. This diagonal here is 8. This bottom side is 4. And they're asking us for x, which is this side here. So we're looking at 30, 60, 90. In the notes earlier, we found out that the side across the 30 is labeled as a, across the 60 is a square root of 3, and across the 90 is 2a. So what we're looking at here is we want to look at what side was provided for us. Well, they provided us with two sides. They provided us with the side length of 8, and they provided us with 4. I'm going to work with the side length of 4 because best case scenario is that they give us the side labeled as a. So if that is the side we're working with, we can say here that a is equal to 4. Well, if a is equal to 4, we now have enough information to find x. X is given by our a square root of 3 side. So x is equal to a square root of 3. Understanding this, we already know the value of a. The value of a is 4, so plug it in. What we get here is then that means x has to equal, well, a, which is 4, multiplied by the square root of 3. So x is equal to 4 square root of 3. Okay, but the question said find the length of the altitude. We found the length of the altitude. We labeled it as x. It's 4 square root of 3. Okay, the length of the altitude is 4 square root of 3. But we want to make sure that we're looking at units. Okay, it's 4 square root of 3, and the units in this problem is in centimeters. So that is going to be our answer for this question. Okay. What I would like for you guys to try, kind of like extra credit bonus type problems that you might run into, would be something like we have here at the very end. Okay, looking at number 7 and 8. Okay, for these questions, these are called multi-step special right triangle questions. Okay, what I would like for y'all to at least try is definitely try giving these problems a try. I would start with the angles here. That's 60, then this is 30. That's 60, this is 30, and this is 90. Okay, what I would suggest here is give these a try. Start with separating out maybe the top triangle. So work this out beginning with the top triangle where we're looking at this is 60, this is 30, and you have this side length of 8. See if you guys can figure it out. Okay, if you want to pause the video, I'm just going to put the answers up here just to kind of save some time. Okay. If you had any luck working this out, you would see here that this side is 4. This side across the 60 is 4 square root of 3. So this side here is 4 square root of 3. We're going to carry that over into the next problem. Okay. Realistically, like I said, I'm just going to write the answer here. That's our side across the 30, 4 root 3 in the second triangle. So this would be 8 root 3. Okay, these problems are hard. They kind of require a little bit of thinking and separating the triangles out. Okay, if you tried the next one, just filling in all the side lengths if you want to check your work. This would be, I believe, what is this? 3, no, 2, sorry. This would be 6 root 3 over 3 would be 2 root 3. And this would be 4 root 3. And then this would be 4 square root of 6. Okay, so just if you wanted to check your answers, if you weren't able to kind of try this or you just found this to be way too complicated, please understand that this would be something along the lines of a bonus question. Okay, the expectation is that you were able to do kind of the first 6 problems throughout the notes. And again, as usual, if anything about the notes was confusing or difficult to understand, please make sure you're reaching out to your teacher to schedule time to come in for tutorials.